We have talked about multiple ways to solve quadratic equations. The problem with those methods is that they are specialized. They only are useful in certain situations. Factoring was only useful when the equation was factorable. Solving by square roots is only useful when you didn't have a b term. When those options are not there, we use something called the quadratic formula. The quadratic formula will work with any quadratic equation, even ones that are factorable. It's just that factoring takes less time. So the formula is particularly useful when a quadratic equation can't be solved by factoring. Solved by factoring. And the quadratic formula, once I write it out, you're going to see exactly why we don't use it very often. So x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. So this looks incredibly ugly, and it's a lot of just plug and chug, but there's a lot of room for error. So let's look at the examples down here. It says solve using the quadratic formula. Now we have to make sure that this equals 0. So we'll add 16 to both sides. And you might say, well, I can factor out or divide everything by 2. And you could do that, but the quadratic formula doesn't require it. So we could take this right now and plug it into the quadratic formula, and I'll show you. So x equals negative b. Well, b is 12, so negative 12 plus or minus the square root. B squared is 144 minus 4 times a, which is 2, times c, which is 16. All over 2 times a, or 2 times 2. And what I like to do is I like to get my calculator out and type in what's under the square root. That thing is called the discriminant. Now I'm not going to type the square root part because with the calculator, if I type in the square root of a negative number, I'm going to get an error. So I'm just going to do 144 minus 4 times 2 times 16. And we get positive 16. So x equals negative 12 plus or minus the square root of 16 over 4. And that's going to equal negative 12 plus or minus square root of 16 is 4 over 4. Now, you can divide all of these by 4. Negative 12 can be divisible by 4, and 4 is divisible by 4, and obviously 4 in the denominator is divisible by 4. So you can actually simplify this a little bit by saying negative 3 plus or minus 1. Technically, it'd be 1 over 1, but we don't need to write that. So we're going to have negative 3 minus 1 and negative 3 plus 1, negative 4, and negative 2. That means my solutions are x equals negative 4 and x equals negative 2. Now, you could have solved this one, like I said, maybe by dividing both sides by 2 and then factoring, but I wanted to show you that this formula will work regardless. All right, now looking over here at example number 2, we have to, again, make this equal to 0, so we'll subtract 7x from both sides, so 4x squared minus 20x, and add 25, so plus 25 equals 0. Right. Now we can go through and use the quadratic formula. And again, you may be looking at this and say, can we do something else instead? And that might be the case, but there are times where you may be looking at one of these quadratic equations and trying to do factoring or square root property. And maybe in that time that it took trying that, you could have just used a quadratic formula. The quadratic formula says negative b, but b is already negative 20. So it's going to be positive 20 plus or minus b, the square root of b squared. So b squared, so 20 squared, minus 4 times a times c, all over 2 times 4. And like I did in the last problem, I'm going to type in that stuff underneath the square root into the calculator all at once. So 20 squared minus 4 times 4 times 25. And see, we got 0. That is actually going to make the problem a lot easier. The square root of 0 is just 0. So x equals 20. We don't need to write plus or minus 0. So it's going to be 20 over 8. And that can be simplified. That fraction can be simplified to 5 over 2. And we'll leave it like that. Right, let's look at example number 3. This doesn't equal 0 yet, so we're going to subtract 5 from both sides. So negative x squared plus 2x minus 5 equals 0. Now, with all the other methods we've used, factoring, square rooting, and even completing the square, we wanted our a value to be positive. Since quadratic formula works regardless, we can use it when our a is negative. Now, the other methods you could have used when a was negative, it was just a bit more difficult. This one is not any more difficult if your a value is negative. So negative b, so negative 2, plus or minus the square root of b squared, so 2 squared, minus 4, times a. Our a right here is negative 1, times c, which is negative 5, all over 2 times negative 1. Okay, now this is going to equal, well, let's get the calculator out real quick. Two squared minus 4 times negative 1 times negative 5. We get negative 16. So we have negative 2 plus or minus the square root of negative 16 over 2. Well, we know that the square root of 16 is 4, but because it's negative, it's going to be plus or minus 4i over 2. Sorry, over negative 2. Right, we can divide all of these things by negative 2. We can factor that out or simplify this a bit more. So this is going to be 1 plus or minus. And because it's plus or minus, it really doesn't matter if we change that sign with the 4, because it's still going to be plus or minus. So 1 plus or minus 4i. And you can leave your answer like this. You don't have to separate it and say 1 plus 4i, and 1 minus 4i. You don't need to do that. All right, I want you to try the problems down here and pause the video, try those, and unpause it and see what you get. Okay, here are the answers, so you can check those and see the work that goes with it. Remember, if you can simplify the radical, do so. In the left one, you could not simplify the square root of 73, so we were done. You don't need to break it up into negative 7 plus the square root of 73 over 2 and negative 7 minus the square root of 73 over 2. You could just leave it as one thing like I did there. And then over on the solo, what you needed to have done is break up the square root of 80 into 16 and 5. The square root of 16 is 4. And then you could divide all three of these numbers by 4. And that's how I got my light blue circle. So on the next page, for which examples was using the quadratic not the most appropriate method? Well, the ones up here where we got whole number answers, it probably wouldn't be the best idea. Like example 1, definitely you could factor. Even example 2, you could have factored that. That was a perfect square trinomial. And you could have done that and gotten the answer maybe much quicker. But example number 3 with imaginary solutions, that's going to be one where the quadratic formula works a lot better. Or like the pair one here, the quadratic formula would have worked a lot better. Now, I've alluded to the discriminant before. The discriminant is the stuff underneath the square root, and that's what I typed in the calculator to save a little bit of time. And the discriminant tells us a lot of things. One of the things it tells us is if an equation is factorable. If that discriminant is a perfect square, then we could factor that. Well, let's look up here. I told you that we could factor example number 1, and look at our discriminant was 16. Perfect square. This one is factorable if you get a discriminant of 0. That also tells you that this is factorable. This one has negative 16. That's not a perfect square because that's negative 16. Down here, these were not perfect squares, so they were not factorable. That's just an extra bit of information. The discriminant also tells you the number of solutions. So if your discriminant is positive, there are 2 real solutions, which means you have 2 x-intercepts. You can look at your graph and tell how many real solutions you have. And you can also tell if the value of the discriminant is positive by looking at the graph. If the discriminant is 0, so I type into the stuff under the square root and I get 0, that means there is 1 real solution. And if you look up here, we had that in examples 1 and 2. Example 1, the discriminant was a positive number and I had 2 solutions. In example 2, the discriminant was 0 and I had 1 solution. What if your discriminant is negative, like we had right here? We have 2 imaginary solutions. So let's go put that down, that a negative discriminant means you have 0 real, or we can say 2 imaginary. That means our graph will not touch the x-axis. So that's a good way to see if you're doing something right. If you know that your graph is not going to touch the x-axis, that means you're going to have no real solutions or 2 imaginary solutions. If your graph touches the x-axis exactly, like if your vertex is on the x-axis, then you only have 1 real solution. So we can use that down here and say, hey, what type of solutions are we going to have based on the discriminant alone? So I'll do example number 4, and then I'm going to have you guys try the other 2. So the discriminant, I'm going to write it right here, just so that we don't got to go back and forth. Again, we're not solving the quadratic equation. We're just trying to figure out how many solutions there are. So we only need the discriminant there. So b is 4, so 4 squared minus 4 times a is 2 times negative 4. Type that all into my calculator. 4 squared minus 4 times 2 times negative 4. And we get positive 48. That tells us there are two real solutions. Remember, for these over here, you must get everything to one side. So this is going to be 3x squared, and once we add 4x to both sides, plus 12x, subtract 24 from both sides, plus 12, equals 0. And for the solo one here, 8x squared minus 9x plus 11 equals 0. Okay, so go ahead and calculate what the discriminant would be and tell me the number and type of solutions. Okay, you can see that our answers are right here. Check those. You see that I calculated just the discriminant, and that told me how many solutions and what type they were. On to the next page. We have talked about vertical motion problems already, and we've kind of set them up in a way where we could solve them using the tools that we had at that point. Now that we have the quadratic formula, we can solve any quadratic function, so the possibilities have opened up a lot. These vertical motion problems are similar to the ones we've done before. This up here, when we dropped an object from a building or something like that, we didn't have an initial velocity. We just had the ball or object falling. Now, if we have the ball launched, let's say that I throw it somewhere, or we have a rocket ship being launched, we have an initial velocity, or this v0. So this would be our initial velocity. Initial velocity. And just like in the other problem, h naught is your initial height. So let's look at this example here. A juggler tosses a ball into the air. The ball leaves a juggler's hands 4 feet above the ground, and and has an initial velocity of 40 feet per second. So let's make an equation. H is going to equal negative 16t squared. That's the normal part right here. The initial velocity is 40 feet per second, so plus 40t. Because you notice there's a t right there. Plus our initial height, 4 feet above the ground. So that's the equation we're going to work with. Okay, so now if we look at letter B, it says the juggler catches the ball when it falls back to a height of 3 feet. How long is the ball in the air? Round to the nearest hundredth. All right, so what we're going to do is, instead of saying h is equal to this, we're going to say 3 is equal to negative 16t squared plus 40t plus 4. And what that will allow us to do is we can subtract 3 from both sides, and then we get 0 equals negative 16t squared plus 40t plus 1. And now we can use the quadratic formula. So negative b, so negative 40, plus or minus the square root of b squared minus 4 times negative 16 times c, which is 1, all over 2 times negative 16. So when I type in just the discriminant into the calculator, when I type in 40 squared minus 4 times negative 16 times 1, I get 1,664. So negative 40 plus or minus the square root of 1,664 all over negative 32. Now, normally I would try to simplify this a little bit, but because we can use the calculator, it says round to the nearest hundredth. What I'm going to do is I'm going to have my two answers, x equals, and then I'm going to type in negative 40 and So parentheses, negative 40 plus the square root of 1,640 divided by negative 32. Oh, whoops. I was supposed to... All right, I'm just going to type that all over again. So parentheses, negative 40 plus the square root of 1,664. I forgot to move out, close parentheses, because I want all this divided by negative 32. So we get negative 0.024, round to the nearest tenth would be negative 0.02. We can't really have negative times, so I know that's probably not going to be the correct answer. So then minus, we get 2.52. 2.52. So the positive one is the one we want. The answer is going to be 2.52 seconds. How else could we have solved this equation? We could have used a graphing calculator. Remember, the graphing calculator in the graphing calculator, we could have put y1 as negative 16t squared plus 40t plus 4, and we could have done y2 as 3 and found the intersection point. So that is a viable method as well. All right, so thanks for watching this video. The quadratic formula is a useful tool. It just isn't the most efficient, but like I said, it is something that will always work. So thanks for watching. Make sure to like and subscribe.